Hi, good day and welcome to my second video on vectors. Today we'll be doing two things, something called scalar product and something called finding the angle in between two vectors. So let's get started. First things to remember is that scalar product and angles only works when the vectors has I and j, not a and b and common p and common q. It only works for the I and j to my knowledge. So let me show you how to do scalar product. Scalar product is also known as dot product, and I believe this is the easiest thing you will ever have to do in maths. How scalar product works. If they give you two vectors, well, this is really two vectors. I should already put it in brackets to show you that this vector is separate from this vector. You'll notice each vector has an I and a j, and the other one has an I and a j. So we have two vectors, and this here is the symbol for scalar product or dot product, a little dot in between. It's not the same exact thing as multiply, as some people believe. All you have to do is take the numbers touching I. What number is touching I here? 2. And what number is touching I here? 5. You are just taking the numbers touching the i's and you are going to multiply them. So you're going to multiply 2 by 5. So we're going to take 2 and multiply it by 5. There's a secret multiply in between here. And then we multiply the numbers touching j. The number touching j here is 3, and the number touching j here is not 4, but minus 4. Remember, this minus sign belongs to the 4. So we're going to put 3 and minus 4. And you notice the letters disappeared. The letter I is no longer here. The letter J is no longer here. We're just taking the numbers touching I and J. 2 by 5 is 10, plus 3 by minus 4 is minus 12. You must have a positive sign in between here. But when we did this calculation, we got a negative. So a positive and a negative will ultimately give you a negative. So 10 minus 12 is minus 2. And that's it. We found the scalar or dot product of these two vectors. Let's try another one. So we have two vectors again. I forgot to put the brackets on all of them, but that's okay. All right, so we're going to take the numbers touching I. What number is touching I here? 6. What number is touching I here? Well, minus I is the same thing as minus 1i. You just need to put in the 1. So we're going to take the 6 and multiply it by the minus 1. Plus, you must put the plus. And then we are going to take the numbers touching the j's, which is minus 3, not 3, but minus 3 and 2. 6 multiplied by minus 1 is minus 6. Minus 3 by 2 is minus 6, and there's a positive in between. A plus and a minus, when they touch, will give you a minus, and the answer for this one will be minus 12. Minus 6 minus the next 6 is 12. Here's another two vectors, and this time I wrote it in column form. Remember, when you write it in column form, the top is I and the underneath is j. So this one should make it real easy to find the scalar product. You have to multiply the two I values, which is the two top numbers. 3 by 4 is 12, plus, and then you multiply the two j values. Minus 1 by 5 is minus 5. It just so happens in all of these examples, a positive are coming together to touch a negative, so you get a negative. 12 minus 5 is 7. That's the scalar product for that one. Real simple. This is like the simplest thing you can hope for in maths. All right, slight trick question here. The first vector here has 3i minus 2j, but the other one only has 3j. There's no I value. Well, if there's no I value, that means the I value is just 0. So this can be interpreted as 0i plus 3j. And once again, you multiply the I values. 3 by 0 is 0, plus minus 2 by 3 is minus 6. So a plus and a minus is a minus, so we get minus 6. 0 minus 6. And those are 4 examples on how to find a scalar or dot product. Now, before I move on to angles, I just want to refresh your memory, because when we are finding the angle between two vectors, you need to remember how to find the magnitude of a vector. Now I did magnitude in my previous video, but I don't know what's the time difference between you watching that video and this video, so you might have forgotten. But when you're finding the magnitude, it has to be I and J. No other letters, not A and B, not P and Q. So we are going to find the magnitude of this vector. Let's say it's 3I plus 5J. To find the magnitude of a vector, the examiner could say, hey, find the magnitude and write the word magnitude. Or he could use two straight lines like this. These two straight lines bordering the vector means automatically, hey, find the magnitude. That's a symbol for magnitude. And to find the magnitude of a vector is very simple. You just take the number touching I and you square it. And then you take the number touching the J, square it. Add the two answers and you square root last. Please remember to square root it last. Do not press the square root sign first on your calculator. Most calculators will give you the wrong answer if you use that. So, I can do this in my head, I guess. 3 squared is 9. 5 squared is 25. So we adding it up. 25 plus 9 is 34. The square root of 34 will not give us a good answer, so leave it as a surd. So the magnitude of this vector is the square root of 34 units, or if you want to square root the 34, you will get 5.83 units. I will give you either one correct in the exam, right? Just make sure and round it off to 2 decimal places properly. If the third decimal place is 5 or more, please remember to add 1, right? If it's an add math exam, you cannot round off bad. Round off properly, guys. Okay? So I just refreshed your memory on how to find the magnitude. So, let me show you how to find the angle between two vectors. Let's say I have a vector. Well, I should draw this on this side and do the working on that side. Let's say I have two vectors, A, B, and I have a vector A, C. Let's say the value of this vector is 2I minus 6J, and the value of this vector is, I shouldn't use different numbers, 5I plus 3J. Alright, well, I'll make it harder, minus 5I. Let's say I want you to find the angle BAC. A lot of students get confused by this. They see 3 letters and they don't know which letter they want you to find the angle. Pretend you're standing at B and you're walking to A and then walking to C. So in other words, you're always walking this direction. B to A to C. It's always the middle letter. So they want you to find that angle. Anytime they want you to find an angle, pretend that you are standing by the angle. So I'm going to pretend to have 2 people, well, 2 dinosaurs standing at point A and standing at point A. And the 2 dinosaurs are going to race out from that point. So this dinosaur is going to run outwards from the angle, and this one is going to run outwards from the angle. So they're both running outwards from the angle. So that means the 2 vectors you want to include in the formula, which I have not shown you as yet, is vector AB, because he's running from A to B, and then the pink dinosaur was running from A to C. The reason I'm telling you this is because direction is super important. AB and BA is not the same. They are completely different in vector land. So make sure you get the direction correct. So how do you find the angle between 2 vectors? It's really, really simple. If you want to find the angle A, cos A is equal to the dot product of the 2 vectors involved, AB, dot product, AC. Remember, the dinosaurs was running from A to B, and then A to C. Divided by the magnitude of the first vector, multiplied by the magnitude of the second vector. So it looks a little bit scary, but I guarantee you it's long, but it's super easy. Let's find the dot product of AB and AC. So where can I do that? I'll do the working over here. AB is 2I minus 6J. Dot product, it's AC. AC is minus 5I plus 3J. So well, I should put this in brackets again. How do you find the dot product? You take the two I values and multiply. 2 by minus 5 is minus 10. Then you take the two j values. Plus minus 6 by 3, the two j values is minus 18. A plus and a minus is a minus. Minus 10 minus 18 is minus 28. So that means my top value here is minus 28. Now we have to find the length of AB and then the length of AC. How do you find the length of AB? You take the I value and square it, plus, and then you take the j value and square it. You notice I put the whole minus 6 in brackets and then square it. When you square anything in the world, you will get a negative, you'll get a positive, sorry. Well, not anything in the world, but for CXC purposes, right? 2 squared is 4 plus minus 6 squared. I don't care if your calculator shows you minus 36. You typed it in wrong. Minus 6 squared is positive 36. Take my word on it. And then you square root this. 4 plus 36 is the square root of 40. I'm going to leave it as a third. So the square root of, the magnitude of AB is the square root of 40. Multiply by the square root of AC. Let's find the magnitude of AC. It's going to be minus 5 squared, that's the I value, plus the j value is 3 squared. This is 25 plus 9 square rooted 20. I should be able to do all this in my head. I don't know why I'm using this. You get 34. Oh, well, I wrote 35. Right, so the magnitude of AB is square root of 40, and the magnitude of AC is the square root of 40. So we have to multiply these two things. So let's multiply. Well, can't fit here, but I'm going to multiply the square root of 40 multiplied by the square root of 34. So square root of 40 multiplied by the square root of 34. And we will get 36.88. So all we have to do now is divide these two numbers and cos inverse our answer. Because remember, we want to find A. So we throw across whatever decimal we get here, we have to cos inverse it. So I'm running out of space here. Let's see. 28, negative 28, don't forget the negative sign, divided by 36.88. Oh, we got, when we work this out here, I'm going to put it down here, we will get minus 0.76, and this is equal to cos A. We want to solve for A, so we throw across the cos to get cos inverse. So A is the cos inverse of negative 0.66, negative 0.76, so second function cos, or cos inverse, negative 0.76, and we get 139 degrees and 0.46, roughly. That's the angle between AB and AC. All right, it's really not a complicated procedure. It's actually pretty easy, right? All right. Oh, that's a music track passing. I think someone's getting married. All right, let's give it a few seconds while I load up the next question on how to find the angle in between two vectors. All right, enjoy the free music. Alright, I think I need the whole board for this one since it's such a long question. Alright, you can fast forward at 10 seconds if you want. Alright, let's try a harder question. Let's say here's P, Q, and R. Let's say this is 2I minus 3J, and this is 4I plus 7J. And the examiner asks you to find the angle PQR. PQR. Which angle are they asking us to find? Let's trace the three letters, P to Q to R. P to Q, and then we journey to R. It's always the middle letter. So they're asking us to find this angle here. angle Q, in fact. We have a little problem. I'll tell you what students do. They see two vectors, so then we'll just use these two vectors in this formula. They will say, to find the angle cos Q is the vector PQ dot product PR, because that's what they're seeing in front of their face. They're seeing two vectors. And they're going to say the length of PQ multiplied by the magnitude of PR. And they think they have it correct. But this is wrong, right? Remember, when you are finding a vector, remember you have to put two dinosaurs by the angle. And they are going to race out or walk away from that point. The blue dinosaur is walking from where? Q to R. And the other dinosaur is walking from Q to P. So what are the two vectors involved? QR and QP. So that means we have to find the length of, or the magnitude of QR, and the length, the magnitude, I keep saying length, but it's magnitude, the length of QP. The direction and the types of vectors matter, right? You just can't, not because you see two vectors in front of you, means you're going to throw those two vectors into the equation. The equation has to match the situation of where the angle is located, okay? All right, so sorry for stressing on that so much. It just, it's years of seeing students making the same mistake over and over and over and over. So sorry if I sound a little bit angry. I'm really not angry. Just frustrated, I guess. Sorry about that. I apologize. Okay, so QR dot product QP. We have a little problem. We do not have the vector QR. It's blank at the moment. So we need to find vector QR first. So how do you find QR? To find QR, we are pretending we are starting at Q. We are going to walk from Q to P and then P to R. So Q to P and then P to R. Okay. Right. QP. We are walking against the arrow. Okay. So we have to make everyone the opposite. So this is really minus 4i minus 7j plus PR. We are going with the arrow, so we change nothing. Add up all the i's. Minus 4 plus 2 is minus 2i. And add up all the j's. Minus 7 minus 3 is minus 10. So this vector from Q to R, and I put my arrow, is minus 2i minus 10j. Right, so make sure and take this down. I'm going to have to erase it to make space. So we have the vector QR. Now here's the thing. Let's put in the values here. Right? I'm going to erase this. I need a space. How much is QR? QR, we have it now. QR is minus 2i minus 10j. And we have to dot product it to QP. How much is QP? QP is 4i plus 7j. Wrong. QP, on the board we have PQ. That's the opposite of QP. QP is this way. So that means it's minus 4i minus 7j. This is correct now. We have to dot product these two vectors. How do you find the dot product? You multiply the I values, right? So I guess I could do it over there, but I'm going to write the answer in here. Minus 2 by minus 4 is positive 8, and then the j values. Minus 10, multiplied by minus 7 is positive 70. So to me, the top part works out as 78. All right? So I hope that makes sense. Okay? Let's work out the magnitude of QR. Remember, this is QR. We have to take the I value squared, add it to the j value squared. You notice I'm putting it in brackets and I'm not forgetting all the minus signs. And we have to square root our answer. Minus 2 squared is positive 4 plus minus 10 squared is 100. So this works out to the square root of 104. So the magnitude of this is 104 square root multiplied by the the magnitude of QP. This is the vector QP here. It's the opposite of PQ. This is minus 4 squared plus minus 7 squared, and we square root it. Take the I value squared, take the J value squared. 16 plus 49 square root. 16 plus 49. You get the square root of 65. So this works out as the square root of 65. We just have to work this out on our calculator and cos inverse the answer, because to find Q, we have to throw across the cosine. So let's see what we get here. 78 divided by the square root, by the square root of 104 multiplied by the square root of 65. Okay, seems that I got 0.95 when we round it off properly to 2 decimal places, right? I'm just going to double check that. Divided by, that's all. Give me 1 second. I don't want to make sure I didn't do nothing. I didn't do anything wrong. Yep, it's correct. So now we have to throw across the cos or cosine to get cos inverse. Second function, cosine 0.95. And I got 18.19 degrees. That's the size of this angle, 18.19 degrees. So I really hope that you all understood how to find the angle in between two vectors. Keep in mind that scalar product and angle and magnitude only works when it's I and J, not when it's A and B. Okay? Right? So I really hope that this cleared up a lot, and I might be doing a third video on vectors where I'm going to concentrate on past paper type questions. Okay? So I'm going to align those questions and make it look like the past papers as much as possible. I'm going to try to make it a little bit harder in case the exam comes a little bit harder. Right, so hopefully I'll be alive to make that video very soon. Okay, take care guys.